So in the last lecture, we were discussing about defuzzification methods and we solved some problems on defuzzification methods. So we'll move ahead today and we'll be starting with fuzzy controller problem solving. So if you recollect that we had discussed the block diagram of a fuzzy knowledge based system, right? So what is that fuzzy knowledge based system? What are the different components? Different blocks. So you're taking the inputs, you have the fuzzification of the inputs, and then you have an inference engine in between, right? You have the inputs, fuzzify, you have inference engine, perform defuzzification, and get the output, right? So these were the steps involved in a fuzzy knowledge based system. Similarly, a fuzzy controller is a kind of a fuzzy knowledge based system itself, and it actually was used for solving controller problems. So whatever controller architectures were there, for that fuzzy logic was applied to solve them. Okay, so basically it's a fuzzy knowledge based system only with these components. So if we want to understand the details of how this actually works, we need to look at example scenarios where this can be applied. So for that, let us first look at what are the steps for solving fuzzy controller problems. So these are the steps, one by one we'll go through them. First step is you have to identify the input and output variables and decide the descriptors for the same. Now what do I understand by this? So whatever are the inputs and outputs for that particular problem scenario that is given, you have to identify them and you have to characterize these inputs and outputs in terms of variables. And at the same time, you decide the descriptors for the same. So the descriptors here means the linguistic terms, right? So inputs and outputs will be in terms of linguistic variables, okay? And you will have the linguistic terms or the linguistic values, right? The linguistic values will be the descriptors, which will be the fuzzy sets only for the variables, right? Different fuzzy sets, because for example, if you're talking about temperatures, so temperature you will characterize into by 3 different descriptors. So descriptors will be, say, cold, normal, and hot for temperature. So after identifying the inputs and outputs, you have to characterize the inputs and outputs in terms of these descriptors. Okay. Next is you have to define the membership functions for each of the input and output variables. So whatever you have identified, whatever inputs, outputs you have identified, now next step is you have to fuzzify them. You have to form the membership, you have to decide the membership functions for each of these variables that you have decided. The third step is very important in the sense of modeling a fuzzy controller is you have to form your rule base. So you have to properly characterize the logic that you need to follow in the form of a rule base. So which will have what is known as fuzzy if then rules or fuzzy implications. The fourth step that we have is the rule evaluation or the inference that you need to perform. So once your rule base is done, what you need to do is you have to actually validate whatever you have created. This is the design that you are making for solving a problem. This is a design that you're proposing. So whatever design you have conceptualized up till now, up till the rule base, you have to just validate those rules. You have to evaluate those rules and see whether you are getting some correct, the appropriate output or not. So that is rule evaluation and rule inferencing. How do you infer? So given some actual input to the system. So for example, there is some sensor in that device, which is going to sense the temperature. So the temperature is say 35 degrees Celsius. So given that temperature, what will be the actual output? So the output could be, if you're talking, for example, in terms of for an AC. So you want to actually set the fan speed. So that could be an output. Okay, so it could be n number of outputs depending on the scenario. So based on that 35 degrees Celsius temperature, that is the input that is sensed by the system, you have to actually infer what will be the output. What will be the output for the input received? That is nothing but the rule evaluation. So so all these rules that you have devised, so which of these will fire, which of these will fire, and out of these fired rules, how will you decide what is the exact value that should be the output of the system? So that will be step number 4, that is rule evaluation or inferencing. Okay, now when you talk about inferencing, directly you will not get the output. I told you the output of inference, the output of an inference system or an inference engine is fuzzy, right? So you'll not get a crisp value directly. So there is a step which comes in between. So that step is nothing but defuzzification. So output that you get will be a fuzzy set. So that has to be defuzzified in order to throw that to the real world, to give that output back to the real world. You need to have one more block that is nothing but defuzzification. So if you look at these 5 steps, these are roughly the same steps involved when you are actually talking about the block diagram of a fuzzy knowledge base system. So we'll follow these same steps and we will design fuzzy controller for a given problem. Okay, so with this background, let us look at one such scenario which is given. So the problem is that you have to design a controller to determine the wash time of a domestic washing machine, and the input given to you is dirt and grease. 2 inputs are given to you, dirt and grease, and they have mentioned that you need to use 3 descriptors for the input variables and 5 descriptors for the output variables. Okay, so what is the output here? What is the output for this washing machine? It's given in the wash time. So the first statement read again: to determine the wash time of a domestic washing machine, right? So that is the output. Now what you need to do is you have to derive your set of rules for the action, for the controller action and the defuzzification, and you have to, since you're going to solve the problem, wherever you will have membership functions, you will have to actually sketch the graphs of those membership functions, and you have to show that if the clothes are soiled to a larger degree, the wash time will be more, and vice versa. Okay, so that this is the problem. So we'll go stepwise. We'll follow the 5 steps one by one, and we'll solve the problem. So the first step is to identify the inputs and the outputs, right? The variables you have to decide, the descriptors you have to decide. So the variables are given to us: dirt, grease, and wash time. So for each of these variables, we have to decide what are the descriptors that we'll be using. That is the terms, the linguistic terms or the linguistic values. Now these, it's mentioned again in the question that you have to use 3 descriptors for input and 5 for output. So let us decide the descriptors for dirt and grease. So dirt, what we will assume is, since there are 3 descriptors So we will talk in terms of percentage. For dirt and grease, let us talk in terms of percentage. So let us assume that dirt is 0% to 100%. Okay, this is your assumption that you're making. So you have to write your assumptions. We are assuming that dirt and grease is in terms of percentage. Okay, so dirt is, say, small dirt, then medium dirt, and large amount of dirt. Similarly, so these are the descriptors: small dirt, medium dirt, and large dirt. Okay, so maybe we will decide a range, say 0 to something, 50. You are going to give membership. So each of these, remember, small dirt, medium dirt, large dirt, will be the membership functions that you're going to um, actually decide for dirt. There will be 3 different membership functions which will occupy different ranges in the range of 0 to 100, right? Similarly, you will have for grease. So for grease, you will have 3 descriptors. Okay, 0 to 100. This is the range. Wash time is the output, and for output, what is mentioned is that you have to use 5 descriptors, right? So it's given here: 3 descriptors for input, 5 descriptors for output. Okay, so likewise, you have to characterize the wash time. So let us assume some range. So you can assume some range. I am assuming the range in terms of minutes. I am assuming about the maximum wash time will be 1 hour. So 0 to 60 minutes. This is my assumption. You can change this. You can make it 0 to 120 minutes. That could be your range, right? Because see, whenever you're talking about inputs and outputs, you have to think in terms of the universe of discourse. What is the range in the real world for these values, these inputs or outputs, right? So wash time is characterized in terms of minutes, 0 to 60 max. That is what I have decided here. So now what you have to do is 5 descriptors. So I can say very short time, short wash time, medium wash time, long wash time, and very long wash time. Okay, so these are my descriptors for describing wash time. So this is the first step. This is the first step. Identify the input output variables. Not only that, you have to also decide the descriptors for these and the ranges. So when you're deciding the descriptors, at the same time, think of the range that you are actually going to work with. The next step. What is the next step? The next step is you define the membership functions for each of the input and output variables. Okay. So you define the membership functions for each of the input and output variables. So one by one, for dirt, for grease, for wash time, let us decide the membership functions. Okay. So when we are deciding the membership functions, let us draw the graph. Look at it in terms of the graphical representation, and we'll write down the equations. That is what you have to do. So this is the graph for dirt. Say this is variable x. So let me assume that it is x. Okay, x. So this is mu of x. Right. There are 3 descriptors, so I have to decide. So I am just assuming that this is the range. Okay, and there are 3 descriptors. So remember, so this is the maximum membership function, membership value that we have. We have to characterize these membership functions, okay, in terms of the standard membership functions that we have studied. Now there are so many membership functions, but when we go for problem solving, then we should go for the triangular membership functions. Either you go for triangular, the straight line ones, okay, triangular, increasing, decreasing, Okay, and what else? Trapezoid, you can go for trapezoid as well. Go for the straight line ones. Okay, so that makes it easier to solve the problem. Okay, and that is only expected when you're actually solving the problem as part of the exam. Okay, now when you're going for these functions again, for now let us assume that we are going to use only triangular functions. I'm not using trapezoid. I will solve one problem which uses trapezoid as well, so that you will get the hang of it, because when you use trapezoid, again there is a range of values and the evaluation becomes a little tedious. So as the functions complicate, the evaluation becomes more and more tedious. So now when we are actually drawing these graphs, so for dirt there are three variables, three descriptors with us. The descriptors are small, medium and large, right? So now if I am assuming that small dirt is taking the range of 0 to 50, remember that I will not write something like this. I will not draw something like this, right? This is not small dirt. This whatever landscape that I have drawn here, whatever graph that I have drawn here, it's wrong completely. Why? Because small dirt, I cannot have small dirt like it's small dirt has to have the highest membership here, na? Closer it is to 0, it has to have the highest membership. I cannot have membership as 0 for small dirt at 0. Okay, so the very first function actually that you draw has to be which function out of these three? Out of triangular, increasing, decreasing, which function will it be?
Decreasing.
The decreasing function. Okay, so that is very important. There many students, I don't know what is the problem, but they make these kind of graphs while they design fuzzy controllers, that is three triangles. Okay, so understand intuitively it is wrong. Okay, so I'm assuming that I'm starting this, I'm just using this decreasing point here. Okay, it is up to you. You can have something like this. Okay, just for simplicity I'm just using this. Okay, so it has to be something like this. So this is small dirt, this is medium dirt, and this is large dirt. Okay, and you have to also, when you're drawing this, you have to, when you're solving the problem in the exam, you have to actually also write the membership functions for each of these. Why do you need to write the membership functions for each of these? Because later on, when you are actually going to infer or you are going to evaluate that rule, so you're going to consider crisp values of input. So you need the equations of those graphs. You need the equations of those graphs, so you need to write it down. Okay, so what I can say is, so dirt I is characterized by three different functions. First one is small dirt. Small dirt of x is simply decreasing function. So what is the equation? Equation of this line, small dirt, is nothing but 50 minus x divided by 50, decreasing function. Okay, and the range of x values are between 0 to 50. Okay, next function is the medium dirt function. So medium dirt function is having two subparts. One is in the range of 0 to 50 and one is in the range of 50 to 100. Okay, so when you're, so first one is an increasing one, second is the decreasing triangular function. So what is the equation of this line? It is x minus, it is x divided by x minus 0 divided by 50, that is x by 50, right? Correct. Next, this decreasing one, it is 100 minus x divided by 50, right? So this is medium term. Similarly, you write it for large dot. Okay, so large dot is, it's increasing, so it is x minus 50 divided by 50, range is 50 to 100, right? So you have got the equations for small dot, medium dot, large dot. On similar lines, you can have the equations for grease. Okay, just call the variable y, you will have the same graph and you can have the same equations. Okay, so this variable is y, small grease, medium grease and large grease. Same graph, only thing is this is y. Right, so I'm not writing the equations because they are similar, the same as dot equations. Okay, the last one is wash time. So wash time, you are having 5 descriptors. So 5 descriptors that we had assumed was very short, short, medium, long, very long. Okay, now here you decide the different ranges. Okay, equations you need to write down, it will be helpful for you to solve the problem. For dirt, grease I have not written because dirt and grease equations are same. Okay, now for wash time, let us call the variable as z, which is the output. Okay, you assume the different ranges. I have assumed the total range from 0 to 60 minutes. This is z, this is mu of z. Okay, so you can assume, so I am just assuming some values. Okay, so first one is very short, will be decreasing for the same reason that I explained earlier. Then is short, so I'm just assuming that these are the points where they are cutting. Okay, then short, medium, long and very long. Okay, so very short, medium, long, very long. So now you have to write the equations for each of these. So we'll write the equations. So the wash time, so all 5 descriptors. So the very short, it is z minus z divided by, it's decreasing. It's decreasing. So what should it be? it's a decreasing slope, right? So it is 10 minus z, right, divided by 10 for the range 0 to 10. Okay. Next is short. So short is having two parts. One is increasing, the second is decreasing, increasing in the range this and decreasing in the range 10 to 25. Okay. So the equation for this is z divided by 10, right? Equation for this is z minus, sorry, again. What is the equation of this line? Between, for z value between 10 and 25. What is the equation of the line? You're able to do this, right? Mentally, as I'm writing. It is 25 minus z divided by 25 minus 10, that is 15. Right? Next, the membership function for medium. So medium is again divided into two. One is between 10 to 25. The other is between 25 to 40. So between 10 to 25, what is it? Between 10 to 25, it's an increasing slope. So it is z minus 10 divided by 15. Similarly, for 25 to 40, it is 40 minus z divided by 15. Okay. For long, again, two ranges, 25 to 40 and 40 to 60. So 25 to 40, it is decreasing. Sorry, it is increasing. So it is z minus 25 divided by 15. And the second line, this line equation is it's a decreasing line. So it will be 60 minus z divided by 20, right? Is this correct? Please verify it. Huh? I might make a mistake. So very long time, the last function, it is z minus, it's an increasing function, z minus 40 divided by 20, right? So the value of z is between 40 to 60. Okay. So these are the functions which are there for input and output. We have written the equations. This completes the second step. Okay. With this, we move on to the next step. That is, you need to form a rule base. Okay. So when you're forming the rule base, you have to consider the effect of the combined effect of the input variables. So these combinations are, you can write when there are two variables, you can write in the form of a matrix. So this rule base, you can write in the form of matrix. These are if then rules which are fuzzy in nature. They use fuzzy logic rather than Boolean logic. I will discuss a bit more about implications a little later after we solve these problems. Okay, so right now we just need to characterize the rules, decide the rules. So what are the rules? So if the rule is going to read like this: if dirt is small and grease is small, then wash time is dash, right? So example rule is, if dirt is small and grease is small, then wash time is, what is the wash time? So based on the knowledge, the domain knowledge, these rules have to be formulated and some intuitive logical reasoning. Okay, so we right now, assuming that we have very little domain knowledge, we'll use our logical reasoning to form these rules, to write these rules. So if dirt is small and grease is small, then the wash time should be very short, right? Very short wash time, very less amount of dirt and grease both. So wash time is very short. So I'll write that very short here. So I'll write the descriptors of output variable here in these blocks, right? So this, what we are doing is we are just combining the inputs and we are assuming the role of both inputs. So that is why we are using and. However, you can also use or. So we will definitely see one example where the kind of rules that are written make use of or. Okay. So if dirt is small and grease is small, then wash time is very short. Okay. Similarly, we will form all the remaining rules. How many rules will this matrix have now? 9 rules, because there are 3 descriptors in input, 3 descriptors in output. So the total number of rules is 3 cross 3, right? The matrix is 3 cross 3. So 9 rules. Okay. So we will write 9 rules. So small dirt and medium grease. When the dirt is small and the grease is medium, then you have to decide what we should put here. Okay. So should it be very short, or what should it be, or should it be short? Okay, so I can write this as short, say, if I write this as short. Okay, now what I should think of is that grease is comparatively difficult to remove from the cloth, right? So what we can do is, since medium grease, when I say grease, dirt versus grease, when I compare the two, so grease will be very difficult, it will be more difficult to remove comparatively. So that is why I can assume that here, since the grease amount is medium, it has jumped considerably. I can make this, instead of short, as what else? Medium wash time. Very short, short, medium wash time. Okay. So let me put an oblique here. I'll finalize this later on. I'll just put an oblique. So its possibility is small and medium, both. Similarly, for medium dirt, small grease, here I can increase this very short to short. Okay. Then large dirt and small grease. So here I can have, what can I have? Small and medium, short wash time and medium, either of these two. Okay. Similarly, medium dirt, medium grease, both are there to a considerable extent on the clothes. So what we need to do, let us assume this is medium, this could be medium or it could be long wash time, right? Similarly, small dirt and large grease. Small dirt and large grease. What will come here? will increase, na? It will increase or it will be same. So either you can have medium or you can have, sorry, either you can have medium or you can have large or long wash time, right? Then medium dirt and large grease. Then in this case, it can be large, long or very long wash time. Okay. Similarly, large dirt and medium grease. This could be, okay. And since these two are large, so in definitely very long wash time. Okay. Now wherever there is an oblique, intuitively this is somewhat correct, but I need to use only one descriptor in every block. So I cannot write, I will not write two different descriptors there, only one descriptor. So what do I do? The thumb rule of writing this rule basis, like you have to see the distribution of the output descriptors. So usually whatever is there in the medium range, middle range, that is, now since there are 5, so very short, medium, long, and very long wash time. Okay, so this have to be very few. So since there are only 9 rules, so I'm using 1. These has to be 2, 3, 2, 3. So accordingly 2, 2, 2 or something like that. Okay, accordingly I decide the distribution, so that in my rule base there is everywhere there is some proportion of a descriptor. Okay, so here what I will do is, here I can keep this as, it is my intuition and some logic that I'm using, that I will make this as medium because grease is medium, so let me assume this as medium. Okay, and from medium, since now grease is more, I have increased it more, I'm making it as long wash time. Okay, here what I do is, both are medium, so I can keep this as medium or this can be long. Okay, because dirt has also increased, but dirt has not increased to a large amount of dirt. Okay, so here what I will do is, if I keep this as large, this will become definitely very large. Okay, if I keep this as medium, then this will become large or long wash time, right? So I'm choosing this as medium and making this as long. Why I'm not making this as very long is because I just want to restrict this to 1. Okay, and then what I do here, same logic, since this is large dirt, I can make this as medium. Then when I make this as medium, what will this be? This will be very this will be long, and then this will be very long. So this is my rule base now. Okay, you could have some similar values, the other values that we had written, but this is what I have chosen. Okay, just remember that whatever the extreme ends, that should be very minimal. Since it's only 9 rules, 1 I'm keeping. Rest you just distribute it. Okay, so this could be this just distribute it 2 or 3, whatever. So this is short, I will make it as, okay, this is short, I will make this as short. I'll keep this as short because this is a dirt that has increased. So I'll keep this as short only. I can keep this as short. Okay, so that is the idea. It could be medium also. There's no problem with that. Okay, but it has to be correct. But I cannot do something like this, that I just write anything anywhere. Okay, logically that flow has to come. So you are moving, na? You're moving towards the larger values, from smaller to larger values here. Okay, for some combination, for example, I cannot have something like, here I will have long and then it will be somewhere here I will start with long, something like that. I cannot do that. Okay, so intuitively it has to be correct. It will be different for different people. it is based on interpretation, but intuitively it has to be correct. That means for medium dirt and medium grease, I cannot have something like short time or very short time, right? So that is about the rule base. Now once this rule base is ready, this is our third step, we will do the inferencing, okay, or the rule evaluation. So for that, let us assume some crisp inputs. So the crisp inputs that we assume is dirt is 60% and grease is 70%. So suppose this is the input that we are looking at. Okay. So how do we evaluate the rules? So for evaluating the rules, what we need to do is we need to look at where actually this 60% and 70% comes on the in the range of the fuzzy functions that we have defined, fuzzy membership functions that we have defined for dirt and grease respectively. So for dirt to be 60%, that 60% range, where does it lie? So I'll go back to the membership function for dirt. Okay, where is this 60 lying? 60 is lying somewhere here, right? This is 60, this range. So it falls under what? It falls under which membership functions? Yes. Which membership functions does it fall under?
medium dirt and large dirt.
Medium dirt and large dirt. So to actually find the fuzzy value for 60, 60 is a crisp value. Now you need to fuzzify it, right? The step is fuzzification. So to find that, you need to look at the graphs, where in what range it is lying. So it is lying in both medium dirt as well as large dirt range. So I have to look at the corresponding equations for each of these lines. So one will be a decreasing line, one will be an increasing line. Okay. So I will use these two graphs and I will look at the fuzzified value. Okay. So let me write this down. So my dirt, the mu value of dirt is in two regions. One is in medium dirt, okay, and one is in large dirt. What is the equation for medium dirt? Let us go back. We have written down the equations. What equation? There are two equations. Which one you will use? The second one. It is this range, right? 50 to 100. Yes, 50 to 100. So the second one you will use, that is 100 minus x divided by 50. Okay. And for large, it is x minus 50 divided by 50. So we will use these two equations. So for mu dirt, it is 100 minus x. X is what? X in this case is 60. We have taken x from the user. Na? We have got that as a crisp value. So 100 minus 60 divided by 50. And what does that give you? It is 40 by 50, that is 0.8. Correct? Similarly, for large dirt, I will get the fuzzy value as, membership value as, whatever the equation is, it is x minus, right, x minus 50, it's an increasing slope, the last line, increasing slope, divided by 50. That same equation I have just written here. Okay. And what is the answer for this? Right, 0.2. Similarly, grease is given to be 70%. So where it lies? Again, that 50 to 100 range it lies. Same equations that we have for dirt, the same equations are there for grease. So we will write down, that means it is there in medium and large range. Okay. So medium grease of 70 is nothing but 100 minus 70 divided by 50. Same equations we have, right? In the medium range, same equation. Large range also same equation. We have assumed the same ranges. Okay. So that is nothing but 3 by 5. What is that 3 by 5? 0.67 something. Okay. Similarly, 0.6. Yeah. Then large dot. Large grease. Large grease 70 is nothing but 70 minus 50 divided by 50. And what is that? 0.4, right? So these are the values that you get. So you have got a fuzzy, the value of 0.8, 0.2, 0.6 and 0.4. Now what do we do with these values? Okay. What we do is we look at that region in the fuzzy, the rule base, where these combinations, where these rules actually hold. Okay. So we have medium dot, large dot, medium grease and large grease. Okay. So that means all of these cells are not, we are not going to look at these. We are going to look at medium dot with medium grease. Okay. Medium dot and large dot with medium grease and large grease. So all these only we are going to look at. All the combinations we are going to look at. Only of medium large dot with medium large grease. Okay, and that is our region of interest. That is what we are going to use to evaluate the rule. Now what we do is next we say medium dot and medium grease. If the dot is medium and the grease is medium, we are looking at the rules right now. So after we get the fuzzy values, we are looking at the rules, because our rules are fuzzy rules. That is why we require the fuzzy values. So if the dot is medium and the grease is medium, okay. So when I do an AND, whenever I do an AND, I use the min operation. So since my rules are using AND as a connective, I use the min operation. So dirt is medium and grease is medium. So we look at this value and we look at this value and we use the min operation. Okay. So I say min of 0.8 and 0.6. And what is that? 0.6. So that value I write it here. I just write the min of these two values here. Okay. Again, same logic I have to use. Because I'm using AND as the connective, I'll be using min operation. If OR is the connective, then I use the max operation. Okay. So when we solve that kind of a problem, we'll look at that example as well. So min, I'm using an everywhere. So if the dirt is medium and the grease is large, second column, this one, second block, this block. If the dirt is medium and the grease is large, then again minimum of these two. So dirt is medium and grease is large. So 0.8 and 0.4. What is the minimum? 0.4. Okay. Dirt is large, grease is medium. So dirt is large, 0.2, and grease is medium, 0.6. Minimum of these two, that is 0.2. Are you getting it? Again, large dirt with large grease. So large dirt with large grease, minimum is 0.2. Okay. So I write these values. Okay. Once I write these minimum values here, I pick up the maximum value. I pick up the maximum value of these. Okay. And that value actually I'm going to use, that value I'm going to use for evaluating, for defuzzifying. Okay. So why am I picking up the maximum value? Because I'm using some rule of defuzzification, some method of defuzzification is the mean of max. We'll be using the mean of max. Okay. So first of all, we look at the max value, and from that we'll be finding the mean of max. We'll be applying mean of max. That is what we are going to do. So first of all, these values you have. So actually, if you want to graphically look at it, it is somewhat like this. So these are my rules which were firing actually. So medium dirt, medium grease, graphical. This is a graphical representation of whatever we had values which we had written in the previous line. So if the dirt is medium, okay, for that value 60 and 70 of dirt, 60% of dirt and 70% of grease. So dirt is medium, okay, grease is medium, the min of these two, okay, that you're projecting actually, these are the inputs, these are the inputs, these are the inputs, right, and this is the output, okay, that actually you're going to project here. So whatever you're getting here, the minimum of these two values, so 4 by 5 and 3 by 5, what is the minimum? 3 by 5. So 3 by 5 actually you're going to use, and you're going to clip off this. Why this medium? This is output, that is wash time. Why you're using medium? Because in that particular block, rule base, go to the rule base, wash time is medium, wash time is medium. So that 0.6 whatever we have got, that is corresponding to the output. That 0.6 that you have written, that is corresponding to the output, that is the wash time. Okay, similarly, that the wash times were medium for those cells, you know, these cells, medium, long, long and very long. These were the wash times which were there. So that is what is given graphically. So again, medium dirt, large grease, okay, take the mean of the two, this one. So if you take the main operation, use the main operation, you are clipping off the output membership functions which were there, and when you actually write it on a combined plot, when you aggregate everything, that is what we did, if you remember, for defuzzification. We had different membership functions and we are clubbing together everything. We are taking union of everything. That is nothing but you are aggregating that. So you are aggregating the output, okay, and that is what you get. So you are getting this. This is the first one. This is the second one, right? Third one, fourth one. When you combine everything, you get this kind of an overall output function, okay. And for this overall output function, you need to apply the defuzzification method, any one of the defuzzification method. Now, when we talk about the simplest way of doing it is we use mean of max. Okay, so we are using mean of max. So if you're using mean of max, you need to look at the max peak and then apply mean of max. Okay, that is why we're taking the max value here, 0.6, and then we're applying the mean of max. So 0.6 is the the value, the membership value for which particular rule, this particular rule. If dirt is medium and grease is medium, then wash time is medium. Okay, so wash time is medium. So what you need to do is, for this particular wash time is medium, this was the thing on the graphically. We need to find out the defuzzified value. What is the wash time we need to find out? We have the membership. From the membership, we need to find out the defuzzified value. So what do? You have the equation. You have the equation of medium wash time or no? You have the equation of medium wash time? Yes. So we use the equation of medium wash time. And then what we do is we equate that to 0.6. Okay, so if you look at the equation of medium wash time, what is that? There are two parts to the equation. One is Z minus this one, see. One is Z minus 10 divided by 15, and the other one is 40 minus Z divided by 15. So you equate that equal to 0.6. Equate each of these to 0.6 and get values. Okay. So the first one will be Z minus 10, that is one equation, divided by 15. Okay. And the second equation is 40 minus Z divided by 15. These are the two equations. Okay. Z is between 10 to 25 and Z is between 25 to 40. Okay. Now what you do is z minus 10 divided by 15 is equal to 0 0.6. Okay. So you will get one value of z. Let us call it as z1. So z1 is nothing but, you just solve this equation. 15 6 are 90. So 9 plus 10, that is 19. Okay. Similarly, for the second equation, you find the z value. What is the z value? Let us call it z2. Z2 is 15 6 are 90. 9 40 minus 9 31. Okay. What are these actually? These are the values which you saw in the previous graph. This is, see, ये equation था, ऐसा ये triangle बन रहा है ना one पे. This was the equation, right? This was medium wash time. Now what is happening is it's clipped off this. This is 0.6. So 0.6 यहाँ पे इसकी value क्या है? This is the first value, lowest value of this particular range, right? And this is the highest value. The second z2, z1 is the lowest value, so left hand side, and z2 is the highest value. Now what you need to do is you need to take the mean of these two values. That is the defuzzified value by the mean of max method. Yes or no? Okay. So 19 is the lowest value, 31 is the highest value on that peak, the clipped off peak. Okay. And the defuzzified value by the mean of max method is just taking the mean of these two values, that is 19 plus 31 divided by 2, that is nothing but 25. Okay, so you get it to be 25 minutes. The defuzzified value you get, so when that is 60 70, you get it as 25 minutes. You can take higher values of dirt and grease like 80 and 90%. Okay, and see, you will see that the wash time will increase. Of course, it has to increase. It will increase. So this is how defuzzification is done. So given a value, how to decide the time in which the clothes will be washed, how to set the timer. The timer will be set automatically. If you use fuzzy control, it will be set automatically. So that is how the time is decided. Okay. So this completes the last step, that is defuzzification. So you are just using mean of maxima, and you have also seen how actually it is interpreted graphically, how you are getting the overall output, and how the mean of maxima is used to compute the defuzzified value. Okay. So that's about this particular problem. In the next lecture, we'll solve more problems on this, which will use different types of rules and different types of membership functions.